Are scientists critical? We often think that they are. Scientists don't just believe everything they are told. Instead, they want to see cold, hard evidence. And they will come to their own conclusions based on what they see. Furthermore, it is precisely because scientists are so critical that science is so successful. Because we take nothing for granted in science, we can quickly discover and get rid of any errors. And that allows us to leave those errors behind and march on towards the truth. This idea of the scientist as a critical thinker is so deeply ingrained in our conception of science that the Austrian philosopher Karl Popper even turned it into the key component of his theory of science. According to Popper's falsificationism, scientists are always busy trying to prove their own theories wrong. They are very critical indeed. Pseudoscientists, on the other hand, are always trying to protect their theories. They are not critical at all. So for Popper, being critical is like a definition of being a scientist. And many people agreed with his idea. But not everyone. Thomas Kuhn, an American physicist, historian and philosopher of science, developed an extremely influential account of science according to which the idea that science is critical is mostly an illusion. Or to be more precise, it is an illusion most of the time. Most of the time, Kuhn argues, science isn't very critical at all. It's only at specific and exceptional moments in history that science becomes critical. So if we believe that science is always critical, we are mistaking the exception for the rule. In these lectures, we're going to delve into that. Kuhn's theory is based on his own work as a historian of science. When Kuhn studied the history of science, he didn't see a chaotic succession of events. Instead, what he saw was a kind of pattern of alternating phases, of different kinds of science that happened at different moments and which followed each other in a standard way. According to Kuhn, you could see this pattern everywhere, in all the sciences, or at least all the natural sciences, and throughout history. So, what are the phases that Kuhn identified? There is first the pre-paradigmatic phase, and I'm going to explain the meaning of these terms later on. Second, there is the phase that Kuhn calls normal science. Third, there is the phase of crisis, and fourth, there is the phase of scientific revolution. Every science, Kuhn tells us, starts in a pre-paradigmatic phase. At some point it will move on to the phase of normal science. Once that has happened, that scientific discipline will never return to the first phase. So pre-paradigmatic science happens only once for any scientific discipline. The other three phases, however, will occur many times. From a phase of normal science, we can move to a phase of crisis. From a phase of crisis, we will return either to normal science or go on to a scientific revolution. And from the phase of scientific revolution, we will always go back to normal science. Normal science really is the usual state of things. It's the phase that we are in most of the time and that we always return to. So to understand Kuhn's theory, we first need to understand what normal science is. That means I'm going to skip over the pre-paradigmatic phase for now and focus on normal science in this lecture. In the next lecture, we will talk about the other phases. Kuhn's key insight is that although scientists are usually critical about new ideas and cutting-edge theories, there is also a lot that scientists are not critical about. Every scientific discipline, Kuhn says, has a huge number of theories, ideas, concepts, methods, measuring instruments and so on that all the scientists in that field simply take for granted. They are never critical about them and they generally don't even discuss them. So to take an example from the natural sciences, biologists nowadays all take for granted the idea that our bodies consist of cells, that these cells contain DNA, and that this DNA contains the genetic information that determines, at least to a certain extent, what we look like and how we act. They also take for granted that the microscope is a good measuring instrument, that modern chemistry gives us a correct account of molecular reactions, and so on. Or to take an example from the humanities, every modern historian takes for granted that Julius Caesar was killed in 44 BC, that Rome became an empire soon after that Roman historians like Livy are not always accurate, that if the claims of such a historian are contradicted by archaeological evidence, the archaeological evidence should generally be thought of as more reliable, that our standard Latin dictionaries and grammars are mostly correct and therefore good tools for translating inscriptions, and so on. All these things, theories, concepts, methods, whatever, that a scientific discipline takes for granted is what Kuhn calls a paradigm. Paradigm, that's a very important concept. Normal science is by definition that phase of a scientific discipline when there is a well-functioning paradigm. That is, a paradigm that the scientists in that discipline are confident about. As the historian will be confident about everything I have just been enumerating. Now, Kuhn goes on to make two important points about paradigms during normal science. First, he points out that they consist of things that scientists don't just take for granted, but that they don't even want to be critical about. Scientists believe that it would just be a waste of time to be critical about the paradigm. Imagine the reaction of a historian if you told her that maybe Julius Caesar didn't really die in 44 BC, but that he survived the attempted assassination and then went on a long and secret journey to China. Or if you told her that maybe our Latin dictionaries are completely wrong and that every Roman text we have means something utterly different from what we think it means. She would not be very interested in pursuing those ideas. She would just roll her eyes and get on with serious work. You could never write your BA thesis about such a hypothesis. So we see that during a phase of normal science, people are not interested in being critical about the paradigm. Second, Kuhn points out that this is a good thing. It is only because we take so much for granted that we can get any detailed work done in science. If a historian couldn't trust the archaeologists and the dictionaries, and if she had to question all the basic facts of her discipline all the time, then she would never be able to make much progress. We can only answer detailed questions about history or about any other subject because we can take a large theoretical and methodological background for granted. It is only that because there is so much we don't have to think about that we can really focus our thoughts on the single question before us. So let us return to the question of whether scientists are critical. According to Kuhn, they're not all that critical, because they don't criticize their paradigm. There's a lot of stuff that scientists just take for granted. Just like there's a lot that you as students are simply taught as the facts and not supposed to be critical about. And Kuhn goes on to say that this is good, because if we were being critical all the time, we could never get any work done and there would be no scientific progress. But if that's true, why do we nevertheless believe that science is critical? According to Kuhn, that has to do with the other three phases of science, which we'll talk about in the next lecture.